Hey everyone, ready to dive into some serious physics.
Oh, yeah.
Today we're talking about black holes, but not just the usual they suck everything up stuff. We're going deeper
Yeah,
into the mystery of what happens to information when it falls into a black hole.
right.
The big question, does a black hole just obliterate information,
Mhm.
which would kind of break some fundamental laws of physics?
Yeah.
Or is it somehow saved?
hmm
The sources you gave me suggest some pretty crazy answers, like
Yeah.
quantum mechanics, relativity, even the idea that the universe is like a giant hologram.
It's really wild stuff.
Oh, I know.
Yeah.
So, where should we start?
Well, I think it all goes back to Stephen Hawking back in the 70s.
Oh, yeah.
He realized that black holes aren't completely black. They actually radiate energy.
Wait, hold on.
We call it Hawking radiation.
How can something so dense that even light can't escape radiate anything?
It seems impossible, right?
Totally.
Yeah. Well, picture the event horizon, the boundary of a black hole,
Huh?
like a super intense region of space-time where quantum mechanics really takes over.
Okay.
And those tiny particles and antiparticles that can pop in and out of existence?
Yeah, from quantum mechanics.
Exactly. Well, sometimes those pairs form right at the event horizon.
Oh, wow.
One particle falls in, the other escapes.
Okay.
And that one that escapes, that's what we see as Hawking radiation.
So it's like the black hole is slowly evaporating.
Kind of, yeah.
But then doesn't that create a whole new problem?
Yes.
Like, what happened to all the stuff that fell in?
Uh-huh.
Where'd all that information go?
Exactly. This is what's called the information paradox.
Okay.
In quantum mechanics, information can never be truly destroyed, right?
Right.
It might get all mixed up or spread out,
Yeah.
but it's always there.
Okay.
So if black holes evaporate completely and the radiation they emit is just random energy, no information about what went in,
Right.
wouldn't that mean the information's just gone?
Poof.
Yeah.
That seems like a pretty big contradiction in physics.
It is a huge one,
Yeah.
and it led to some really fascinating ideas to try and resolve it.
So what are some of the solutions from the sources?
One that really caught my eye was the concept of black holes as entropy storage units.
Okay. Entropy. That's the measure of disorder, right?
Yeah,
What
exactly.
does that have to do with black holes?
So it turns out a black hole's entropy,
Okay.
its measure of disorder,
Uh,
is tied directly to the area of its event horizon, not its volume.
wow.
So think about it like a black hole the size of a basketball
Okay.
can only store as much information as you could write on the surface of that basketball,
Wow.
not all the space inside it.
That's crazy. It's like saying my computer's hard drive can only hold as much information as can fit on its label.
It's a weird concept.
Yeah.
Right.
So are black holes like the universe's organizers or something? Sucking up entropy and keeping things tidy?
It's an interesting way to think about it.
Yeah.
They might actually help to maintain some kind of order in the universe
Okay.
by concentrating all that disorder, all that entropy inside themselves. But it gets even stranger.
Danger.
Yeah, when you bring in the idea of holography.
Holography. You mean like those 3D stickers you used to find on everything?
Exactly. That's
Yeah.
a perfect analogy. Just like a 3D image can be encoded on a flat surface,
Right.
some physicists believe that the information that falls into a black hole might be encoded on its two-dimensional surface.
The event horizon.
Yeah, like a cosmic hologram.
So the information isn't gone.
Oh.
It's just encoded in a way that we can't really grasp.
Exactly. It's called gauge-gravity duality. It points to a deep connection between gravity and information.
Yeah.
And if this is true, it could totally change how we understand the universe. It might even help us understand how gravity works at the quantum level.
So we've got black holes as cosmic organizers and the possibility that information is like a giant cosmic hologram. This is getting pretty intense.
Oh, yeah.
Are there any other explanations in the sources?
Yeah, there are even wilder ones, like the idea of black hole remnants and the firewall hypothesis.
Oh yeah, those sound pretty wild. Let's talk about those next.
Okay.
Black holes as cosmic organizers,
Mm-hmm.
and then this idea that information is like a giant cosmic hologram.
Yeah,
It's mind-blowing.
it is.
But the sources also mention some other really wild ideas, like black hole remnants
Yeah.
and this thing called the firewall hypothesis.
Uh-huh.
What are those all about?
Okay, well, remember we were talking about how black holes evaporate because of Hawking radiation?
Yeah.
So some physicists think that they might not completely disappear.
Hmm.
They say that there could be this tiny, super dense thing left behind. They call it a remnant.
So even though the black hole seems to vanish, there's still a tiny little piece of it left,
Yeah.
holding all that information. Kind of like finding a needle in a cosmic haystack.
Exactly. And these remnants would be incredibly small,
Okay.
like subatomic small,
Wow.
almost impossible to detect.
So they'd be pretty hard to find then, right?
Yeah, but here's what's interesting. Some physicists think that these remnants exist in a realm beyond our usual understanding of space and time, a place governed by quantum gravity,
Oh, wow.
which is something we're just beginning to understand.
So these black hole remnants could be the key to unlocking some of the biggest mysteries in the universe. That's amazing.
Right.
It's incredible that something so small could be so important. What about that other idea you mentioned?
Oh, the firewall hypothesis?
Yeah, that one sounds kind of intense.
Yeah, it's definitely one of the more controversial ideas out there.
Okay.
It suggests that the event horizon of a black hole isn't actually smooth.
Okay.
It says that there's a region of incredibly intense energy, like a firewall, that incinerates anything that tries to pass through.
Whoa, hold on. So instead of falling into the black hole, you'd get fried at the event horizon?
Basically, yeah. It's pretty traumatic, right?
Yeah. It's a far cry from the classic picture of a black hole.
It is, and it raises even more questions about the information paradox.
How so?
Well, if information is destroyed by this firewall, right at the event horizon,
Yeah.
wouldn't that still go against the laws of quantum mechanics?
It would seem so. So it's like we're stuck, right?
Yeah.
Information can't be destroyed.
Right.
But if it gets past the event horizon, we don't know what happens to it either.
Yeah.
It's like a cosmic catch-22.
It's a puzzle that's baffled physicists for decades,
I bet.
but it's also pushed us to make incredible breakthroughs in how we understand the universe. And, the sources you gave me,
Yeah.
they also suggested something even more fundamental, like a totally different way of thinking about information itself, something about geometry.
Yes. It sounded like maybe information isn't just something that's inside the universe, but that it's actually woven into the very fabric of space-time.
That's a powerful way to look at it. And this is where Einstein's theory of general relativity comes in. Remember, general relativity describes gravity as the curvature of space-time caused by mass and energy.
You're right.
So what if somehow information is encoded in those curves and warps?
So instead of black holes destroying information, they're actually encoding it into the structure of space-time itself.
Exactly. And it's not just passive encoding. Some physicists believe that this information could be actively shaping the black hole and how it interacts with the rest of the universe.
So then the universe is like a giant quantum computer,
Yeah.
processing information through the curvature of space-time. That's amazing.
Yeah.
But is there anything to actually back that up?
Wait, there are some interesting clues. Physicists use these mathematical tools called metrics to describe the geometry of space-time around different objects.
Okay.
And the interesting thing is these metrics, they look like abstract equations, but they could actually represent information itself.
So you're saying information isn't separate from the universe, but it's actually a fundamental part of its structure?
Exactly. It's a huge shift in perspective.
Yeah.
And it's driving some of the most cutting-edge research in theoretical physics today.
Okay, so we've gone from black holes evaporating to firewalls to the universe being a giant information processor.
Yeah.
Wow, we've covered a lot.
We have.
What's next? Well, my brain is officially fried.
I know, right?
We've gone from black holes as cosmic vacuum cleaners to the idea that the universe is like a giant quantum computer.
It's a lot to take in.
Yeah, I need a minute to process all of this.
It is a lot.
But amidst all this mind-bending theory,
Yeah.
we have to remember that black holes aren't just theoretical playthings.
Right.
They're real objects out there in the universe, shaping galaxies, influencing how the cosmos evolves.
Absolutely.
So what can you tell me about black holes as actual physical objects? The sources mentioned something about supermassive black holes.
Yeah, so while we've been focusing on the theoretical mysteries, there's a whole other side to black holes that's just as fascinating.
Okay.
We now know that supermassive black holes, millions or even billions of times the mass of our sun, are at the center of most galaxies,
Really?
including our own Milky Way.
Wait, you're telling me our entire galaxy is orbiting a supermassive black hole?
Yep, it's true.
I had no idea.
And for a long time, these supermassive black holes were seen as these monsters, just lurking in the dark, devouring anything that got too close.
Right.
But recent research has shown that they play a much more complex role in how galaxies evolve.
So they're not just cosmic vacuum cleaners.
Not at all.
What else do they do?
Well, as matter falls into a supermassive black hole, it releases a ton of energy.
Okay.
And this energy can actually trigger the formation of new stars in the surrounding galaxy.
Wow. So black holes are both destroyers and creators.
Yeah, kind of a powerful duality.
It's almost poetic.
It is, right? This interplay between destruction and creation is what drives how galaxies evolve over billions of years.
That's amazing.
Black holes may seem enigmatic, but they're an essential part of the cosmic dance.
This has been an amazing journey.
It has.
We've explored so many fascinating ideas about black holes,
Uh-huh.
from Hawking radiation to the possibility that the universe is this giant information processor.
Yeah.
As we wrap up, any final thoughts you'd like to share about black holes or any takeaways for our listeners?
For me, what stands out is the sheer wonder of it all.
Yeah,
Black holes push us to the limits of what we understand,
they do.
forcing us to question everything we thought we knew about the universe.
Hmm.
And the amazing thing is, we're always learning more. New telescopes and observatories are giving us these incredible views,
Right.
revealing secrets we could never have imagined.
Yeah, the more we learn about black holes, the more we realize we don't know.
Exactly.
It's a good reminder that science is a journey, not a destination.
Totally agree.
There's always more to discover, always more questions to ask. So for our listeners out there who want to keep exploring, I'd leave you with this.
Okay.
If information is truly encoded in the geometry of space-time, what does that tell us about the nature of reality? Is the universe we perceive just a projection of some deeper, more fundamental reality, like a cosmic hologram playing out on space-time?
That's a question that'll keep philosophers and physicists busy for a long time.
I think you're right.
It's the beauty of it all, isn't it? The universe is vast and mysterious and endlessly fascinating.
Well said. So keep looking up at the stars, keep those brains buzzing, and until next time, happy exploring.